Hello everyone, welcome to the third video on differentiation. I hope you have already understood basic differentiation technique that we had discussed earlier. Also, we have discussed all the standard derivatives. Now, this topic chain rule is where your actual syllabus in class 12 starts. So this is the most important portion in your class 12 syllabus. Remember, if you do not understand chain rule, many more chapters, many more lessons that we are going to do will be very, very difficult for you. So please pay attention to this topic very, very carefully. So chain rule is the basis of differentiation, and differentiation later becomes the basis of integration. So if you don't understand chain rule, let me tell you, many more lessons to come, maybe 20 to 30 lessons to come, will be very, very difficult for you. Is that clear? So please understand this properly. So what is a chain rule? So chain rule is basically applied to find the derivative of a function of a function. So or a composite function. So it says a chain rule is used for a composite function. So now we are quite aware, we are quite unaware of a composite function. Let's see what is a composite function. The definition says if y is a differentiable function of z, and in return z is also a differentiable function of x, then y is said to be a composite function of x or a function of a function x. Here z acts as a bridge variable. It says y is actually a function, y is a function of z, but again in return z is a function of x. So two-step function, isn't it everyone? Let's have an example. Let's see the example. This is an example of a composite function. How? Actually, this function was supposed to be y equals to sine z, let's say, isn't it everyone? Or you may say y equals to sine x. Yes, this function was supposed to be y equals to sine x, but instead of a normal variable x, there is another function inside the function, isn't it? So can I put it this way? So let's say I can write y equals to sine z. I can break this function. Now this function can be broken down as a composite function. How? Let's say y equals to sine z, and in return what is this z? Z equals to 2x plus 3. So did you see that? So first step, y is a function of z, and second step again z is a function of x. So this way z forms a bridge, isn't it everyone? So z is a bridge variable. So whenever this type of situation arises, then we say such function is a composite function. So how can you break the second one now? Check the second one. So let's say y equals to z to the power 5 is a normal function. Then again in return z is 2x plus 7. So did you see that if I replace z here, then I get the original function. So I see it is a two-step function. Y is in terms of y can be written in terms of z, and again z in return can be written in terms of x. So these type of function is called a composite function, where another function is contained inside the function. Are you understanding? Example, the third one, check the third one. Normally it had to be y equals to log x, or you may say y equals to log z, isn't it? But again z in return is equals to sine x. So you see z is replaced inside. So the subject of log contains another function which is sine, isn't it? So that's why we say it is a function inside a function. That's why it is called a composite function. So such functions are called composite functions. By the way, pause the video right in the beginning and copy all this. I want you to copy all this in your notebook. Okay, so this type of functions are called composite function, and to differentiate this we need a special rule which is called a chain rule. So now here we have to differentiate a composite function, what do we use? Chain rule. So in general, by the way, in general, can we write a composite function in this way? So first of all, y will be a function of z, and in return z will be a function of x. So how do you ultimately find dy by dx? Because there is a bridge variable in between, isn't it everyone? So how do you differentiate such function? So for that it is done step by step. Check this out. So first of all, in order to find dy by dx, what do you need to do is you need to differentiate the function in terms of z first, and then in return differentiate the second function in terms of x, and then multiply them together. Let me show you. So it might be a little confused. So the first, let's see the first one itself here. Okay, the first one is y equals to, let me show you that, y equals to sine 2x plus 3. Okay, so this is a lengthy process. There is a shortcut process for this as well, but try to understand this first. So can I write y equals to sine z, replacing this by z, and in return, can I say z equals to 2x plus 3? Is that okay? I'm breaking up the function as a composite function. Now they say, first find dy by dz. What do I find, everyone? Dy by dz. So what is differentiating? What is dy by dz? It will be d dz of sine z. What is d dz of sine z, everyone? Everyone knows that's cos z by the standard derivative, correct? And what is dz by dx? Now they are asking us to find dz by dx. So it will be d dx of 2x plus 3. And how much is that, everyone? That's 2, because d dx of 2x is 2, isn't it, everyone? 2 comes out and d dx of x is 1. Okay, so finally, what is dy by dx? Dy by dx, according to the formula, is dy by dz multiplied with dz by dx. So let us put them together. That's a cos z and into 2, isn't it? So that gives me 2 cos z, and replace the z. What is originally z? The z is the value of z is 2x plus 3. So that's the derivative of y equals to sine 2x plus 3. It looks quite tedious and lengthy, because every time I cannot break the function as z and in return z in terms of x and do this. Okay, so we need to learn a shortcut for a chain rule. So what is the shortcut for chain rule? Let me show you. The shortcut for chain rule would be something like this. Let me rub this first. Okay, so the same function, remember the answer, I'm not rubbing the answer here. So this was the answer. So same sum I'm going to do by shortcut method. So y was sine 2x plus 3. Isn't it, everyone? Yes. Remember, this is a composite function. Why? Because we see there is a sine function, and inside a sine function there is 2x plus 3. That's an algebraic function. So there are two functions inside one function. Got it? So how do you differentiate it? So let's directly start differentiating both sides with respect to x. This is the direct method. So this is more preferable. Remember that. Okay, I just showed you the longer method as well, but this is what you will prefer in further sums to come. Correct? So differentiating both sides with respect to x. So this will become dy by dx, and that side it will be d dx of sine 2x plus 3. Careful. What do you need to do is you need to differentiate the function one by one here. That's why it is called chain rule, because when you differentiate one by one, a lot of chain will be created. So first start from the outside function. So start from the outside. So the outside function is the sine function here. Start with the sine function. So what is d dx of sine? Now think, instead of 2x plus 3, there is a big x. Think there is a x here. So if, okay, let me rub and show you. So imagine there is a x here. So what would be d dx of sine x? What would be d dx of sine x? Cos x, isn't it? Isn't it, everyone? Okay, so originally it was 2x plus 3. And just to show you, I have written there x. So imagine this is x. So as I have shown you earlier, so what is d dx of sine x? That will be cos x, isn't it, everyone? But x is 2x plus 3. So did you understand? Again, I'm repeating, I have started to differentiate this from the outside. So I thought that instead of 2x plus 3 there was a x, and then I applied the standard derivative. What is d dx of sine x? Cos x. But there is no x, that is just my imagination. That's why I have to replace it with whatever was there. So it is cos 2x plus 3. Now into, this is where a chain will be created. Now into d dx of another chain, the leftover. What did you differentiate in the first step? Sine. What did you not differentiate? 2x plus 3. So right here 2x plus 3. So that would give me cos 2x plus 3. That's already been differentiated. And what is d dx of 2x plus 3? That's 2. So finally, what is the answer? 2 cos 2x plus 3. So did you understand this? So check this out. This was the answer in the previous case also. So same answer we got in this shortcut method as well. So did you understand? What about this? Y equals to x squared plus 2x to the power 4. Does it follow a chain rule? Let's see it carefully. Normally, it should have been x to the power 4, but instead of x, there is x squared plus 2x. So definitely it is a chain rule. So how do I do it? Differentiating both sides with respect to x. And let me do that. So this will be dy by dx, and let me put the operator d dx here. So x squared plus 2x to the power 4. So imagine this is x. I need to handle the power first. Okay, imagine this is x. What is d dx of x to the power 4? Let me write here, d dx of x to the power 4. You know it. It's 3, sorry, that's 4x cubed, isn't it? By using the formula x to the power n, that's nx to the power n minus 1. So that would give me 4x to the power 3. That's x square plus 2x, because my x here is x square plus 2x. I have imagined this is x, into, I need to follow and make a chain. What should I differentiate now? I should differentiate the bracket, because this was what was left out. So x square plus 2x and 4x square plus 2x whole cube into ddx of x square 2x and ddx of 2x 2. So I get 2x plus 2 into 4x square plus 2x whole to the power 3. A little rearrangement, take 2 common and multiply with 4. 2 will be out, 2 into 4, 8 ultimately, x plus 1 and x square plus 2x whole cube. I repeat again, I have taken 2 common from here and multiplied with 4. 2, 4, 8, and then left over is x plus 1, x square plus 2x whole cubed. Okay, let me show you another example. Look at this function. So here I have y equals to log sine x square. Remember, there are this is a 3-step chain. How do I know? Because normally it is supposed to be log x, but instead of x there is a sine x square, isn't it everyone? So normally it has to be, it was supposed to be log x, but instead of x there is sine x square. And inside the function here, inside this highlighted one, it is supposed to be sine x. But again, instead of x, there is a x square. So there is a 3-step, log x, sine x, and x square. So when I split this function, I see this function as a 3 functions, log x, sine x, and x square separately. Got it? So a 3 chain will be created here. So let's start how to differentiate. Differentiating both sides with respect to x. So I get dy by dx equals to ddx of, check this out, log sine x square. Please remember, I'm applying shortcut method here as well. Long method I won't prefer at all, so I'll just try to do it by shortcut method. So first, what functions to handle? Log, the outside one. Let's handle log first. So that will give me, imagine this is x. So what is ddx of log x? 1 by x, isn't it everyone? So 1 by sine x square. Correct everyone? Because there was no x was just an imagination, so I have to write whatever is here, whatever is the subject of log. So but the format of the formula will be the same. So had there been x here, it would be 1 by x. That's why I write 1 by sine x square. Now which function did you handle? Log, the highlighted one. Now what is left? Sine and x square. So sine and x square can also not be handled together. So secondly I'll handle sine into ddx of sine x square, 1 by 1. Next, 1 by sine x square, by the way, into, what is ddx of sine? Imagine this is x. What is ddx of sine? Because there is no formula of sine x square, so I'll have to think it as sine x. So what is ddx of sine x? Cos x, but there is no x, there is a x square. So cos x square. Is that correct everyone? Whatever is here, I need to copy it here. And the third chain now, finally, what did I not differentiate? X square is the last thing I have to differentiate now, isn't it? So what is ddx of x square? 2x. So finally I get 1 by sine x square into cos x square. And what is ddx of x square? 2x. So simplify, put them together. So let's write 2x right in front. 2x into cos x square divided by sine x square. And the answer is 2x into, that's cot x square. So finally the answer, 2x cot x square. Did you understand everyone? So that is the derivative of y equals to log sine x square. Here there was a 3-step chain, so that's how I create one after the other. Step by step I will have to differentiate if there is a function inside another function. Okay, what about y equals to e to the power sine x square? So let's start. So first I will differentiate e. Then I will differentiate, let me show you in different color. Then I'll differentiate sine. Then I'll differentiate x square, because there is a, okay, that's green, okay, x square. Correct everyone? So differentiating both sides with respect to x. Remember, it's a composite function. How do you know? Normally it's supposed to be e to the power x. Next step it's supposed to be sine x, isn't it? But and finally there is a x square. So you see, instead of x there is a sine x, and instead of this there is a x square. So that's why it's a 3-step chain. So do you understand this? Now how would you differentiate this? Differentiating both sides. So dy by dx equals to ddx of e to the power sine x square. Correct? Then let's start with e. Imagine this is x. So what is ddx of e to the power x? that's e to the power x, but there is a sine x square, correct? Then followed by ddx of, now next was done sine x square. So then comes e to the power sine x square. What is ddx of sine x? It is cos x. So instead of x, I have to write x square, and followed by ddx of x square. So finally the answer is, I will write ddx of x square is 2x right in front, then I'll write cos x square, then finally I'm going to write e to the power sine x square. That's just a simple way of arranging it properly. So did you understand, everyone? So that is the derivative of y equals to e to the power sine x square, done step by step using chain rule. Okay, the next one, if y equals to log of e to the power x divided by e to the power x plus 1, prove that dy dx equals to 1 by 1 plus ex. So this function definitely is a composite function, because normally it's supposed to be log x, but instead of x there is a ex divided by ex plus 1, isn't it, everyone? So this has to be done by method of chain rule. Okay, let me rub this and start. So differentiating both sides with respect to x. So what do I get? Dy by dx equals to, I'll have to write ddx, let's put the operator, log ex and ex plus 1. So where do I start with? I'll start with log. So that gives me, what is ddx of log? Imagine this is x. Imagine this is x. So what is ddx of log x? That is 1 by x, but x means ex plus 1. Got it? Into ddx of, now I've already done log, next is ex divided by ex plus 1. Correct, everyone? Okay, so that gives me, this flips and moves up. You know the rule, ex. And now how would you do this? Do not forget the basics. This is to be done by quotient rule. This looks like u, this looks like v. So you know the quotient rule. Second, that's v, ex plus 1, into ddx of first, that's ex, minus first into ddx of second, ex plus 1, divided by second whole square. Correct, everyone? That's how it is supposed to be done. Okay, let me rub this now. Okay, now that gives me, let's close this, ex plus 1 divided by ex, that's by the way dy by dx, into, what is dd, okay, what is ddx of ex? That's normal ex, so I'll get ex plus 1 into ex. Okay, and what is ddx of ex plus 1? ddx of ex is ex, and ddx of 1 is 0. So that's also ex, ex into ex. Correct, everyone? Divided by ex plus 1 whole square. The square and 1 ex plus 1 gets cancelled. Okay, then comes dy by dx equals to 1 by ex, look carefully, into this ex whole square plus ex, how? Ex into ex, ex into 1, minus ex whole square. Ex whole square gets cancelled. I'm left with ex plus 1 in the denominator. Correct? Okay, and finally 1 by ex, and there is a ex in the numerator left, and ex plus 1. So ex gets cancelled, and I have the answer 1 by ex plus 1. So hence proved, because that's what you need to prove. The next one, what about y equals to tan x e to the power x square? Does it follow chain rule? Definitely. Normally it has to be tan x, but instead of x there is x e to the power x square. And again here also, check this out, this had to be e to the power x, but instead of x there is a x square, isn't it? So there is a chain here in tan, and there is a product rule here because the function is being multiplied, isn't it, everyone? Then there is again a chain rule. So let's do it. Differentiating both sides with respect to x. So I get dy by dx. That side I need to write the operator ddx of tan x dot e to the power x square. Look carefully. First I'll start with tan. So what is ddx of tan x? ddx of tan x is sec square x. That's e to the power x square. That's everything inside the bracket acts as a x. Correct, everyone? Now followed by ddx of chain. You have to create a chain. The bracket is x e to the power x square. Correct, everyone? But you know now this follows product rule, isn't it? U into v, because two functions are multiplied together. So that gives me, let me do it towards the extreme left, x e to the power x square. And you know the product rule. What is the product rule, everyone? Second, that is e to the power x square, into ddx of first, that's x, plus first into ddx of second. Correct, everyone? Okay, now this gives me sec square x e to the power x square. Careful. And here, what is ddx of x, everyone? That's 1. No need to write. So e to the power x square plus. Now this again, check this out. Let me highlight. This again follows chain rule. Why? Because it's normally x. And instead of x, there is a x square. I have already shown you here, isn't it? So what is ddx of e to the power of x? That's e to the power of x, because instead of x there is x square, into what is ddx of x square? Shortcut 2x. Can I write like this? Again I repeat, ddx of e to the power x square is e to the power x square, because x square acts as x. Then there is a function inside a function. It has to be e to the power x. Instead of x there is x square. And what is ddx of x square? 2x. Isn't the small chain there composite function? Okay, that gives me sec square x into e to the power x square and e to the power x square plus 2x into x. This can be multiplied, not a problem. That will be 2x square e to the power x square. Correct? So finally the answer is, let me rearrange this a little bit. Okay, so I will get can I take out e to the power x square common from here? So e to the power x square is common. I get 1 plus 2x square. Is that correct? Then I'll get a sec square x e to the power x square. So that would be a proper way of arranging this. So did you understand? That's the answer for this sum. Okay, I'm trying to give you as many examples as possible for chain rule so that you understand it properly. Okay, the next one is y equals to log x plus x square plus 1. Definitely this is a chain composite function, because instead of x there is x plus under root x square plus 1, and further there are many chain involved here. Okay, so let's do it one by one. So now I can write dy by dx equals to ddx of, differentiating both sides with respect to x, by the way, log x plus under root x square plus 1. Correct? Okay, so that gives me, this is log x. What is ddx of log x? 1 by x, and that's my x, isn't it? The green part is x. Correct? Into, create a chain, ddx of the green one, x plus under root 1 x square plus, sorry, x square plus 1. Correct? Okay, now that gives me 1 by x plus under root x square plus 1 into, what is ddx of x? You can distribute, that's 1 plus, this is ddx of under root x square plus 1. Correct, everyone? So I haven't done that. That's a chain rule again. How is this a chain rule? Now you may wonder, how is this a chain rule? Because normally it should be x to the power something n, but there is a x to the root x. That means that's x to the power of half. And inside there is no x here. Inside the root there is supposed to be x. Instead of root there is x square plus 1. So that's why I can make it as a chain rule. Okay, so have a look, everyone. I'll show you. Into, let me write you 1 plus ddx of, how do you handle it? This can be written as x square plus 1 to the power half, because everyone knows square root means, this square root means what, everyone? To the power half. Correct? Or else you can directly differentiate the root. What is ddx of root x, by the way? What is ddx of root x? You know it. Look at the top right here. ddx of root x is 1 by 2 root x. If you remember, I have done this in earlier classes, isn't it? So let me show you here. That gives me 1 divided by x plus under root x square plus 1 into, that's 1, and this is ddx of root x. Okay, for your if you want to do it, you can do it at the side and write it down here, but you will get the same thing. That is ddx of root x is 1 by 2 root of x, and that's the x, because I think I am imagining this is x. Okay, but there is no x, there is x square plus 1, so that's why it will form a chain, one more chain, and ddx of x square plus 1. Correct? Okay, so let me rub here now. Okay, that gives me 1 by x plus under root x square plus 1. Look carefully into bracket 1 plus 1 by 2 root x square plus 1, and ddx of x square plus 1, ddx of x square is 2x, ddx of 1 is 0, so 2x, and I can cancel the 2 and the 2. So finally I get x under root x square plus 1 into 1 plus 1, x under root x square plus 1. Correct? Okay, so that's what we have here. Let me rub this as well. That gives me now 1 by x plus under root x square plus 1 into, what is the square root? LCM, x square plus 1. You will get under root x square plus 1 plus x, because there is a 1. You know how to take LCM. So this and this gets cancelled, and I'm left with root x square plus 1. So that's finally dy by dx. So you might want to look at, repeat and watch this video again for this sum specially. Okay, please do that if you haven't understood. Okay, this one would be the last one for today. Y equals to sine square 3x plus 2. Check this properly. There is a square, sine square. So remember, normally it is sine x, there is a square. Okay, so even powers are composite function, because there shouldn't have been sine x square. Instead, you know, sine x whole square can be written as like this, isn't it? Sine square x can be written as sine x whole square, and normally there should have been x square, but instead of x there is a sine x. Remember, that creates a chain. That's why power also comes under chain rule. So can I write it like this? Y equals to sine 3x plus 2 and a bracket and whole square. Now you understand that this power is a chain, because this should have been x. So I handle first the power. Correct? So dy by dx, ddx of sine 3x plus 2 and whole square. So what is ddx of, let's say, something square? That's x square. That's 2x, isn't it? So let me put it in place. 2 sine 3x plus 2, because that acts as 2x, because this, by the way, this you see is a x for me. Correct? So 2x. Now multiplied by, create a chain, everyone. Let me rub here. Create a chain. What would be my chain? ddx of, you have already done the power. Now time to do the highlighted one. ddx of sine 3x plus 2. So now out of these two, again there is a composite function here. It should have been normally sine x, but instead of x there is 3x plus 2. So I handle first sine, then I'll handle 3x plus 2. So still I have to do 2 times. So 2 sine 3x plus 2, and what is ddx of sine x? Imagine this circled one is x. That's cos x. Correct? And finally ddx of the circled one, 3x plus 2. So what is ddx of 3x plus 2 directly? That's 3, because ddx of 3 comes out, ddx of x is 1 and ddx of 2 is 0. By the way, if you are not aware of the standard derivative, I want you to mug up the standard derivative. You have to understand, you have to remember the standard derivative to solve the sums. Remember, okay, remember the standard derivative chart. So that gives me, by the way, this is 3. So 3 into 2, directly I'm doing 3 into 2, 6. Can I do that? Because ddx of this one is 3. So 3 to 6. And I write here sine 3x plus 2 cos 3x plus 2. So that would be my answer. You can use formula and combine it, but it's okay. So did you understand? So this much for today. Please solve the homework sums provided. Thank you.